know that feeling? When software almost works, and the button looks fine, but click it, error message, or the app seems great, but then it just freezes.
Oh, absolutely. And think about it, so much runs on software now.
Right, it's fundamental. So reliability isn't just nice, it's essential.
Totally. When things go wrong, it's not just annoying. It can mess up work, communication, sometimes even bigger things. Making sure it's all solid is a huge job.
Which brings us neatly to today's deep dive. We're looking into a really interesting approach called gray box testing.
Yeah, and for you listening, this is a neat way to understand what goes on, behind the curtain to make the software you use more reliable, smoother.
Like a backstage pass for tech testing.
Kind of. You'll get a key concept pretty quickly. No comp sci degree needed.
Exactly.
Yeah.
We've dug into some sources that explain what gray box testing actually is, the techniques they use, and really why it matters for making software better.
So our mission today basically is to unpack the core ideas of gray box testing.
And get why it's valuable for the tech we all rely on. Okay, let's kick things off. In simple terms, gray box testing. What are we talking about?
Okay, imagine you're trying to figure out a complex machine. Black box testing is like you can only see the outside, the buttons, the switches, no idea what's inside.
Yeah.
White box testing, that's having the full blueprints, every wire, every gear laid out.
Got it. Total visibility.
Right. Gray box is, well, it's in the middle. Testers have some idea of the internal structure, the inner workings, but not like the entire detailed source code.
Ah, okay. So maybe like a high-level map of the main systems, but not down to every tiny screw.
Exactly that. And the point of having this partial knowledge is to find bugs, defects related to maybe an awkward bit of code structure or maybe ways the software is used that weren't quite expected.
Yeah.
And what's interesting is it's often really good at finding those context-specific errors. You see those a lot in, say, web systems.
Because they have so many parts working together, like the front end, the code, the database.
Precisely. You've got all these layers. By having some insight into how they connect, gray box testing can really boost the coverage, how thoroughly you test the whole complex thing.
It lets you focus your energy better.
Yeah, focus where issues are more likely to hide.
That makes a lot of sense.
Okay.
Okay, so why this middle path? Why not just stick to black box, the user view, or go full white box and dive deep into the code? What's the big advantage?
Well, the real power of gray box is that it genuinely combines the strengths of both. Black box focuses on the user experience. Does it do what it's supposed to?
Yeah.
Which is crucial.
Yeah, absolutely.
And white box is great for checking the code's logic, the structure itself. Gray box sort of gives you the best of both worlds.
So you're getting that user perspective, but it's informed by some knowledge of what might be weak points internally.
Exactly. You're not just checking if it works, but you also have clues about why it might be failing or where potential problems might be lurking under the surface. It helps build a more robust product in the end.
Okay, sounds smart. Efficient, too.
It often is, yeah. Because you're not just randomly poking buttons like pure black box, and you're not painstakingly checking every single line of code like pure white box.
White?
It can save quite a bit of time and effort for both the basic functions and the trickier non-functional stuff. And plus, when a tester does find an issue, having that bit of internal understanding helps the developers fix it much faster.
Okay, so it's quicker, more targeted, finding the problems, and it still keeps the user's needs front and center.
That's the idea. The user interaction is still a primary driver for designing a lot of the tests.
All right, so we get the what and the why. Let's talk how. How does someone actually do gray box testing? What's the strategy?
So the key thing is testers don't necessarily need the full source code in front of them.
Okay.
Instead, they use what they know about, say, the algorithms being used, the overall system design, maybe how it handles different internal states, or even just high-level descriptions of how the program should behave. They're looking a bit deeper than just the screen.
So they might know clicking button X kicks off process Y behind the scenes, even without seeing the actual code for process Y.
Exactly. That's a good way to put it. And while it often builds on black box techniques, designing tests based on requirements, what it's supposed to do, the gray aspect is using that partial inside knowledge to design smarter tests that are more likely to hit those potential weak spots.
Right, so it's like black box, but with better intel for planning the mission. So
Yeah, something like that.
Okay. Now, I know there's specific techniques involved here. What are some of the main ones people use in gray box testing?
Yeah, there are a few key ones. One is called matrix testing.
Matrix testing.
Yeah, think about software that has lots of different settings or variables the user can change. Matrix testing is basically a systematic way to test different combinations of these variables together.
Okay, like
hmm
if you had a photo editor, maybe testing different brightness settings combined with different contrast settings.
That's a perfect example. It's about covering the various states and inputs. Then another really important one is regression testing.
Ah, yeah, we hear about that a lot with software updates. How does Graybox fit in?
So when developers change something, fix a bug, add a feature. Regression testing is all about making sure those changes didn't accidentally break something else that was working fine.
Right, the classic fix one thing, break two others.
Exactly. In Graybox, because testers have some understanding of the system's structure, they can be smarter about where to focus their regression tests. They might know which parts are most likely affected by the recent change.
So they don't necessarily have to rerun every single test every time.
Yeah.
They can be more strategic.
Precisely. They can target the risky areas, the bits that interact with the changed code, much more efficient. Then there's orthogonal array testing, OAT.
Okay, that sounds technical.
It sounds a bit complex, but the core idea is actually about efficiency. Imagine you want to test how different ingredients affect a recipe, but you don't want to try every single possible combination, which could be thousands.
Right. OAT is a statistical technique that helps you pick a smaller, manageable set of combinations that still gives you really good coverage of how those different factors interact.
So it's a smart way to get maximum testing, bang for your buck, without testing absolutely everything.
You got it? Maximum coverage, minimum test cases. Another valuable one is pattern testing.
Pattern testing.
This one looks back at the history of defects. What kinds of problems have cropped up before in this system, or maybe in similar systems?
Okay.
But unlike black box, which just sees the failure, gray box pattern testing uses that partial internal knowledge to try and understand why those past failures happened. What was the underlying pattern or weakness?
So it's using history to predict future problems, but with a bit more insight.
Yes, exactly. Understanding the why of past bugs helps you design tests that are much more likely to catch similar issues if they pop up again.
Learning from mistakes at a deeper level. Pretty much.
Yeah.
And just to add, Graybox often relies on automated testing tools to run these tests efficiently. Sometimes testers also create simplified stand-ins for parts of the system. We call them stubs or drivers.
Like temporary parts.
Yeah, to help test other components in isolation before the whole thing is fully built.
Okay, so it's a mix. Informed human strategy, plus automation and maybe some testing aids. Got it. What about the actual process? If I were doing this, what are the steps?
Generally, it flows something like this. First, you'd clearly identify all the inputs the software might get and all the outputs it should produce. Basic stuff.
Inputs and outputs. Check.
Then you try to identify the major paths through the application and its key subfunctions, kind of breaking it down logically.
Mapping out the main journeys and components.
Exactly. Then, for each of those subfunctions, you develop specific inputs and figure out what the expected correct output should be.
Designing the mini-tests for each part.
Right. Then you run those test cases for a subfunction, check the results carefully against what you expected. Did it pass? Did it fail? Okay.
And then you basically repeat that execute and verify cycle for all the different subfunctions you identify.
So it's systematic. Testing piece by piece, but guided by that higher level understanding of how the pieces fit. Makes sense. Where does this approach really pay off the most? What kinds of testing?
Oh, it's pretty versatile. It's really good for testing GUIs, graphical user interfaces, because you're looking at both the user interaction and the code behind the buttons and menus.
Right.
Super valuable for security testing, too. Having some grasp of the architecture helps you look for potential vulnerabilities someone might exploit.
Yeah, I can see that.
Database testing is another big one. You often need some knowledge of the database structure to properly test how the application reads from or writes to it.
Makes total sense. Also great for browser compatibility testing, checking across different operating systems, or just general functional testing. Does it do the job? And because it bridges that gap between external and internal views, it's especially good for things like web applications and web services where you have that constant communication between the user side and the server side.
Okay.
Security assessments also use these techniques a lot to probe for weaknesses.
So, yeah, pretty broad range of applications then. Is it all smooth sailing, or are there challenges? Any downsides to Graybox?
Well, like any approach, it's not perfect. One potential issue is sometimes if a test triggers a failure deep inside some operation,
Yeah.
the whole process might just abort, stop suddenly. And that can occasionally make it tricky to figure out exactly where the root cause was.
Ah, the crash hides the evidence a bit.
Sometimes, yeah. Another challenge can be when a test runs all the way through, no crashes, looks fine, but the actual result it produces is wrong.
Oh, like a calculation error?
Exactly. Or it saves the wrong data. If you're not also thinking about the internal logic, those subtle errors can sometimes slip through.
So even with the extra insight, you still need really careful analysis of the results.
Definitely, it helps a lot, but it doesn't replace thoroughness.
Okay, so let's bring it all home. What's the big picture here? Why should we, or anyone building or using software, really care about gray box testing?
I think fundamentally it comes down to cost and quality. Gray box testing can seriously reduce the overall cost associated with software bugs.
How so?
By finding problems earlier in the whole development cycle, and because you often have a better idea of why something might be failing, you stop those bugs from getting further down the line where they become much harder and much more expensive to fix.
Right, catching them early saves time, money, and probably a lot of headaches later on.
Exactly. And the direct benefit of that for everyone is software that's just more reliable, more stable, less frustrating to use. Better software for you, the user.
So, summing up then, gray box testing.
Hmm.
It's like this really smart middle ground. It's not testing blind like black box.
Right.
And it's not getting totally lost in the weeds of every line of code like white box. It uses that really valuable partial knowledge to test more effectively, more efficiently.
That's a great way to summarize it, yeah. Having some of that internal insight lets testers design smarter tests, find a wider variety of problems, and ultimately help build software that works better and is, more user-friendly. It respects both the user's view and the system's internal health.
It's actually fascinating, isn't it, how that idea of partial access, not zero access, not full access, but something in between is the key here. Makes you think, maybe, about how the amount of information we have affects how we tackle problems everywhere, not just software. Maybe sometimes having just enough insight, but not being overwhelmed by all the detail is actually the sweet spot for figuring things out in life, too.